Now I'm going to introduce a concept that will be very helpful in helping you determine what to do. I'm going to introduce the discriminant. The discriminant will not give you answers. It will tell you the type of answers and will help you decide which way that would be easiest to solve a particular problem. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a is called the quadratic formula. The part with the square root is called the discriminant, the part under the square root. The b squared minus 4ac is called the discriminant, where it's the part under the radical. This part is called the discriminant. Now, one good thing about the discriminant, if b squared minus 4ac, in other words, if the discriminant is a perfect square, then one thing, you'll know your solutions are rational. Now, let's see why that is. If the discriminant is a perfect square, then I can take the square root of it. If I take the square root of it, I no longer have a radical. If I no longer have a radical, then everything would be fractions. So fractions are rational solutions. So if I can take the square root of my discriminant, then I'll have rational solutions. Now that's important in another way. If I have rational solutions, that means I could have gotten them by factoring. So if the discriminant is a perfect square, then the polynomial ax squared plus bx plus c will factor. Now that's probably the most helpful thing I'm telling you, because remember how hard it was to determine whether a given polynomial would factor? Now that we have the discriminant, all we need to do is to evaluate the discriminant, and if it is a perfect square, then the polynomial ax squared plus bx plus c will factor. Excuse me. If b squared minus 4ac, in other words the discriminant, is positive, then the solutions are real. So if b squared minus 4ac is positive, then the solutions are real. Now let's go back and see what that means. If the discriminant is positive, that means that you can approximate the square root of it with your calculator. If you can approximate the square root with your calculator, then you can write the answers as decimals. Real numbers are numbers that can be written as decimals. So if b squared minus 4ac is positive, I can use my calculator to take the square root, and I can therefore evaluate it. So the solutions are real. If b squared minus 4ac is equal to 0, then one has only one real solution. Again, if b squared minus 4ac is 0, then that wipes out the plus or minus part. I simply have as my answer a negative b over 2a, which is only one solution. If b squared minus 4ac is less than 0, then the solutions are complex. Now, if b squared minus 4ac is less than 0, that means the discriminant is negative. If the discriminant is negative, that means you're taking the square root of a negative number. If you're taking the square root of a negative number, you are creating the complex case. So if the discriminant is negative, then your solutions will be complex. Let's give an example of how you can apply those facts. Which of the following will factor? Well, let's look at the first one. We have 2x squared minus 5x plus 3. The discriminant is b squared minus 4ac. Well, b is negative 5, so it would be a negative 5 squared minus a is 2, so it would be 4 times 2, and c is 3. Negative 5 squared is 25 minus 4 times 2 is 8. 8 times 3 is 24. 25 minus 24 is 1. 1 is a perfect square. So since the discriminant is a perfect square, I know that 2x squared minus 5x plus 3 will factor. So I'm going to put a check there saying that one will factor. Well, what about 4x squared plus 13x minus 9? Well, I need to evaluate the discriminant. The discriminant is b squared minus 4ac, which would be 13 squared minus 4 times 4 times the negative 9. b squared minus 4ac. Those numbers are getting kind of big, so let's bring in the calculator. And we're going to evaluate the discriminant, which was 13 squared minus 4 times negative 9. b squared minus 4ac, and we get 313. Now 313 is not a perfect square. So since 313 is not a perfect square, we know that it will not factor. So I'm going back and saying this one will not factor. Well, what about x squared plus x plus 1? Well, the discriminant is b squared minus 4ac. Well, a is 1, b is 1, and c is 1, because the understood numerical coefficient is 1. So I have 1 squared minus 4 times 1 times 1, which is 1 minus 4, which is negative 3. Negative 3 is not a perfect square, so therefore it will not factor. So the discriminant gives you a very quick way of determining whether polynomials will factor. Now that's quadratic polynomials. Another good use of the discriminant is to determine what type answers you'll have before you do it. So let's give the type of answers. Well, to find the type of answers, I need to evaluate the discriminant, which is b squared minus 4ac. So it would be a negative 4 squared minus 4 times 2 times 5. Now negative 4 squared is 16, minus 4 times 2 is 8, 8 times 5 is 40, 16 minus 40 is a negative 24. Now if the discriminant is negative, then we have complex answers. Now if you're doing an application that involves real answers or requires real answers, you can stop now and not do any more work. So another advantage of knowing the discriminant, it tells you the type answers. Now notice the discriminant does not tell you the answer. It only tells you the type answer. So 2x squared minus 4x plus 5 has complex answers. Now before I can determine the type of answers x squared is equal to 3x plus 4 has, I've got to put it in standard form. So I need to subtract 3x and subtract 4 from both sides. So I get x squared minus 3x minus 4 is equal to 0. Now I can do the discriminant. The discriminant is b squared minus 4ac. So it would be a negative 3 squared minus 4 times 1 times a negative 4. b squared minus 4 times a times c. Notice that a is 1, b is negative 3, and c is negative 4. That would be 9 plus 16. Negative 4 times 1 is negative 4 times negative 4 is positive 16, which is 25. Now 25 is a perfect square, so that means we're going to have rational solutions. So they're going to be real, rational solutions. This completes tape 127.